electronic signals to it. We can change the color and the shape on the screen with these signals. So maybe we could change a biological living liquid crystal with a special electronic signal. But in order to do that, we would need some kind of device. So we searched the US patent database, and we find this invention by a physician, Dr. James Bear of Albuquerque, New Mexico. It's called a resonant frequency therapy device, and its purpose is to induce a resonant vibration in a living organism or cell. And now we go to the biology laboratory and we take Dr. Bear's device, and the hunt begins through a microscope for a frequency which will shatter a living microorganism. Now we have a method of controlling Dr. Bear's device by an input control frequency. So if I put in, say, 100 hertz, out will come 100 pulses per second. If I put in 200 hertz, we'll get 200 pulses. So now we're searching for the magic frequency. And we start with 100 hertz, and we look through the microscope to see if anything's happening. We watch for 5 minutes. Nothing happens. So over the course of 15 months, we try hundreds and hundreds of frequencies, if not thousands, until we find the magic combination. The answer is you have to have 2 input frequencies, one low, one high, and the higher frequency must be 11 times the lower. It's what we musicians would call the 11th harmonic. When we add the 11th harmonic, we begin to shatter microorganisms like a crystal glass. So now we know we can destroy a microorganism, and the question comes up, but can you target a specific organism with a specific frequency? So in this next video, you'll see a large organism in the center, a paramecium, undergoing disintegration, and swimming all around it, a tiny different organism which is unharmed. So now we have some evidence that we can target specific microorganisms with specific frequencies. And we make several more videos, and we film the destruction of hundreds of microorganisms. And about this time, we meet a cancer researcher, and we show them these videos. And this results in an invitation to spend 4 months in a cancer research lab trying to shatter cancer cells. It also turns out this is the beginning of a process of destruction for cancer cells. We now know that cancer is vulnerable between the frequencies of 100,000 hertz and 300,000 hertz. So now we attack leukemia cells. Leukemia cell number 1 tries to grow a copy of itself, but the new cell is shattered into dozens of fragments and scattered across the slide. Leukemia cell number 2 then hyperinflates and also dies. Leukemia cell number 3 then tries to make another cancer cell. The new cell is shattered and the original cell dies. But killing a handful of leukemia cells is not enough for a patient. What kind of numbers can we do? In repeated controlled laboratory experiments, independently assayed by the 2 top experts, we killed an average of 25% to 42% of the leukemia cells, as high as 60%. They also determined that we slowed the